Hello and welcome to my channel. In this video, we are going to solve a question from Cambridge Pure Mathematics 1, Trigonometric Identities and Equations, which had appeared in February-March 2025 paper. This question has two sub-questions. So let us start with the first question now. Show that 3 tan square theta plus 5 sin square theta is equivalent to 8 sin square theta minus 5 sin to the power of 4 theta over 1 minus sin square theta. So here we have to basically prove that the left hand side is equivalent to the right hand side. So I'm going to start with the left hand side terms and try to prove it equal to the right hand side. Now for the left hand side, we have to make use of certain trigonometric identities, starting with tan theta is equal to sin theta over cos theta. So in the left hand side term, 3 times in place of tan square theta, we have written sin square theta over cos square theta plus sin square theta. Now if we look at the right hand side, we do not need the cos theta. The numerator and the denominator has sin theta. So let us try to get rid of this cos square theta by using another identity, which is sin square theta plus cos square theta equal to 1. Now since we are trying to get rid of cos theta, let us send sin square theta on the other side of equal to sin. So this identity now becomes cos square theta is equal to 1 minus sin square theta. Now in place of cos square theta, we are going to replace it as 1 minus sin square theta. Now rest of the terms stay the same. Now in the next step, let us try to get a common denominator. So here 5 sin square theta can be written as 5 sin square theta over 1. Now here we are going to multiply this denominator with this numerator and also the denominator. And this one is going to multiply with this numerator, that is 3 sin square theta, and this denominator. Now 1 multiplies with 3 sin square theta, giving us 3 sin square theta, plus 5 sin square theta multiplies with 1 minus sin square theta. Now we get a common denominator, that is 1 minus sin square theta. Now let us expand this bracket. So here we get 3 sin square theta plus 5 sin square theta times 1 is 5 sin square theta. Now plus 5 with the minus gives us minus 5. Now sin square theta times sin square theta gives us sin to the power of 4 theta over 1 minus sin square theta. Now here 3 sin square theta and plus 5 sin square theta, they are like terms. So we are going to add 3 with 5, giving us 8 sin square theta minus 5 times sin to the power of 4 theta over 1 minus sin square theta. Now this is equivalent to our right hand side expression. So we have shown that the left hand side is equivalent to the right hand side. This is our answer. Now let us move on to the B question. Hence solve the equation 3 tan square theta plus 5 sin square theta is equal to 9 for 0 degree is less than theta is less than 270 degrees. So here basically we have to find out the values of theta that are lying between the range of 0 to 270 degrees. Now in the part A, we had been given that the left hand side is equivalent to the right hand side. So let us take the right hand side terms because we had the numerator and the denominator in terms of sin theta. So here we have written 8 sin square theta minus 5 sin to the power of 4 theta over 1 minus sin square theta is equal to 9. Now let us take this 1 minus sin square theta on the other side of equal to sign so that it multiplies with 9, giving us 8 sin square theta minus 5 times sin to the power of 4 theta is equal to 9 times 1 minus sin square theta. Now in the next step, we have expanded the right hand side bracket. So 9 times 1 is 9 and 9 times negative sin square theta gives us minus 9 times sin square theta. Now let us take the left hand side terms on the right hand side. So we get, now negative 5 sin to the power of 4 theta goes on the other side of equal to sign and becomes positive minus 9 sin square theta. Now positive 8 sin square theta becomes negative 8 sin square theta on the other side of equal to sign and positive 9 stays the same equal to 0. Now here we can see that these two terms are like terms. So we have combined them together in the next step, giving us 5 times sin to the power of 4 theta. Now minus 9 and minus 8 gives us minus 17 sin square theta plus 9 equal to 0. Now here let us try to get this equation as a quadratic equation And for that, let us use x equal to sine square theta. So here we have written, let x equal to sine square theta. So now sine to the power of 4 theta can be written as 5 times sine square theta raised to the power of 2 minus sine square theta plus 9 equal to 0. So in the first term, in place of sine square theta, we have written x. So this equation becomes 5x square minus 17x plus 9 equal to 0. Now this represents our quadratic equation. And to find out the value of x, we are going to use the quadratic formula, which is x is equal to minus b plus minus square root of b square minus 4ac over 2a. Now here in this formula, a represents the coefficient of x square, so which is 5 in this case. B is the coefficient of x, which is negative 17. And c is a constant, which is 9 over here. So we are going to plug in the values of a, b and c in this formula, giving us minus b is minus 17. So minus of minus 17 plus or minus square root of minus 17 square minus 4 times 5 times 9 over 2 times a becomes 2 times 5. Now let us further simplify this. So minus of minus gives us plus 17 plus or minus. Now let us see what is the value of the square root. So this is going to give us square root of 109 over 2 times 5 gives us 10. So here we have two values of x, that is 17 plus square root of 109 over 10, or x equal to 17 minus square root of 109 over 10. Now since we need to find out the value of theta over here, and we had considered x as sine square theta, so let us replace x as sine square theta now. So here we have written sine square theta is equal to both the values. Now let us take square on the other side of equal to sine for both of these values. So we get sine theta is equal to plus or minus square root of the entire value. And the same thing happens over here. When we send square on the other side of equal to sine, we get two values, that is plus or minus square root of the entire value. Now this is going to give us the value as plus or minus 1.66, and this is going to give us the value as plus or minus 0.81. Now remember that the amplitude of the sine graph ranges between 1 and negative 1. So it can maximum go till 1 and its minimum value is going to be negative 1. But here if you see, here we have got a value which is beyond the range for the sine graph. So we are not going to get any value of theta which is going to give us plus or minus 1.66. So here we are going to simply write that the values are not possible or the values of theta does not exist. Now let us focus on this value, because we can see that 0.81 lies within the range of sine graph. So let us consider positive 0.81 and let us take sine on the other side of equal to sine. So we get theta is equal to sine inverse or arc sine of 0.81. And let us see what value this gives us. Now make sure to keep the calculator in the degree mode. So sine inverse of 0.81 will be equal to 54.095 degrees. Now let us round it to one decimal place, giving us 54.1 degrees. So here we have written theta equal to 54.1 degrees. But we need to find out two more values of theta, because the given range is between 0 degrees and 270 degrees. So for this, let us understand a cast diagram first. Now this can be called as cast diagram or ACTS diagram and so on. So I'll be referring it as cast diagram. Now this diagram helps us to understand where the values of the trigonometric ratios lie. So this is called as the first quadrant, as we can see, which lies between 0 and 90 degrees. The quadrant which lies between 90 and 180 is called as second quadrant. The third quadrant lies between 180 degrees and 270 degrees. And the fourth quadrant lies between 270, and if you come back to the 0 degrees, it becomes 360 degrees. So from the first quadrant, if we move in the anti-clockwise direction, we get the second, third and fourth quadrants. Now all the trigonometric ratios, that is sine, cosine, tangent, cotangent, cosecant and secant, all the values of these trigonometric ratios which lie between 0 degrees and 90 degrees will be positive. So here we have written all positive. Now sine is positive in the second quadrant as well as the first quadrant. So any sine angle which lies between 90 and 180 becomes positive. So for example, sine of 100 degrees is positive, sine of 170 degrees is positive because all these values lie between 90 and 180. Now in the third quadrant, the tan is going to be positive, but the sine becomes negative over here. So for example, sine of 200 degrees gives us negative value, whereas tan of 200 degrees gives us a positive value. So here we have written in the third quadrant, the tan is positive, but if sine and cos comes in the third quadrant, their values are going to be negative. Similarly, if tan and cos lie in the second quadrant, that is, for example, if we have cos of 100 degrees, then it is going to give us a negative value. Now finally, in the fourth quadrant, the cos values are going to be positive for all the values between 270 to 360. So for example, if we have cos of 285 degrees, that is going to give us a positive value. But sine and tan becomes negative in the fourth quadrant. So this represents the cast diagram going anti-clockwise, starting with cos, that is CAST. Now here in this question, we have sine inverse of 0.81. So here we know that the sine is positive in the first quadrant and in the second quadrant. So the first value of angle which we got, that is 54.1, lies in the first quadrant, that is between 0 and 90. Now we have to find out what is the value in the second quadrant as well, because the range of theta given to us is between 0 and 270 degrees. So this values lie between this range. So to find out the value of sine in the second quadrant, we have to just subtract this value, that is 54.1, from 180 degrees. So 180 minus 54.1 gives you a degree which lies between 90 and 180. So that is going to be equal to theta equal to 180 minus 54.1 gives us 125.9 degrees, which is in the second quadrant. Now we have got two values which are in the first quadrant and second quadrant. Now since the range is still 270 and we have got another value of sine theta which is negative 0.81. So let us take theta equal to sine inverse of negative 0.81. So this is going to give us the value as negative 54.095, same as this value. So let us take theta equal to negative 54.1 now. And since the sine value is negative in the third and the fourth quadrant, we cannot go beyond the 270 degrees because the range is only between 0 and 270. We have to take the third quadrant for the negative value. And for that we have to just add 54.1 to 180 degrees. That will give us a value which will lie between 180 degrees and 270 degrees. So here we have written theta equal to 180 plus 54.1 is equal to 234.1 degrees. So this value where the sign is negative lies in the third quadrant. So these are the three values of sine theta, that is 54.1 degrees which is in the first quadrant, 125.9 degrees which is in the second quadrant, and 234.1 degrees which is in the third quadrant. So this is our answer.